Hello and welcome to Math 253, Calculus 3 here at Cañada College. My name is Lapuz and I'm the instructor for the course. In this video we will get an overview for Chapter 4. Chapter 4 talks about functions of several variables. In the first section we'll define these functions of several variables, and then we'll take a look at the graph of these functions. Now, a function of two variables will have a two-dimensional input, and that can represent your xy plane. And then the output will be a one-dimensional value, which will be our z component, and that will bring us to view the graph in 3 dimensions. We're going to bring it back down to 2 dimensions again by looking at level curves and traces. And we do this so that we can picture or attempt to picture functions of 3 variables by looking at their level curves and traces as well. In the next section, we'll take a look at limits and continuity. We're first going to define the limits using epsilon delta. Of course, that's going to be a little bit difficult to deal with, and so we're going to be using a lot of limit laws. And it turns out that looking at things that do not exist, limits that don't exist, will be a little bit easier to prove with limit laws. We're also going to take a look at continuity, and we're going to study again functions of 3 or more variables by looking at their limits and their ideas of continuity. In the next section, we'll take a look at partial derivatives. We'll define partial derivatives like we did the derivatives in Calculus 1. And we're going to estimate these derivatives by looking at those level curves, or sometimes known as contour curves. And we'll take a look at derivatives of functions of 3 or more variables, and also take a look at higher order derivatives, like the idea of second derivatives. In our next section, we'll study tangent planes. Tangent planes are much like tangent lines. They're linear approximations of the functions at a particular point. So we'll study the definition, we'll derive the idea of a tangent plane, we'll take a look at linear approximations and differentiability. We're also going to study differentials of these functions of 2 variables, and then we'll extend that study to take a look at functions of 3 variables. In section 4.5, we're going to take a look at the chain rule. We'll see that the chain rule, or if you recall, the chain rule is a composition of 2 functions. So our first function will be a function of two or more variables. And then we're going to compose that with a function of 1 variable. And we're going to try to compose that with a function of 2 variables as well. And we're going to establish the idea of trying to visualize formulas for these chain rule problems. We're also going to take a look at implicit differentiation. Now, this is the same implicit differentiation that we saw in Calculus 1. We're going to revisit that and extend the ideas of implicit differentiation to functions of 2 or more variables. In the next section, we'll take a look at directional derivatives and gradients. Partial derivatives are really derivatives that move along the x and y axes. In some cases, you might be interested in finding the derivative as we move around another path that's different from the x or the y. In that case, we'll study directional derivatives. We'll define these directional derivatives, and we'll find a way to solve for these directional derivatives using some sort of formula. It turns out that this formula will include a special vector called the gradient. So we're going to study the gradients as well. And it turns out that gradients have special properties, and we're going to dive into that. And we're also going to take a look at gradients and directional derivatives in higher dimensions. In our next section, we're going to take a look at optimization problems. Studying local max and mins becomes the heart of calculus, or at least it was in Calculus 1, and here also in the derivative calculus at Calculus 3. We're going to study critical points and establish the idea of critical points. Now, back in Calculus 1, we had the first derivative test. It turns out that our first derivative test does not transfer so well with higher dimensions. And so we're going to try to remember our second derivative test. And the idea of a second derivative test transfers very well with higher dimensions, and so we'll use that. And then we're also going to study the extreme value theorem by looking at absolute max and mins within a closed set. Finally, we're going to take a look at Lagrange multipliers. Lagrange multipliers are studying the idea of finding max and mins given a particular constraint. So we're going to take a look at Lagrange multipliers with one constraint and tie that into the graphics of level curves. And then we're going to take a peek at looking at Lagrange multipliers with two constraints as well. Okay, so that is our overview for Chapter 4. We're in the middle of our journey, so good luck with your work.